Hi students, today we are going to discuss about message authentication algorithm and hash functions. Continuation with previous topic. Okay, so the outline of today's discussion will be under the authentication requirement and its function, and what is about a message authentication code and hash function, and security of hash functions and max, and message digest algorithm and secure hash algorithm, and about repent 160 and HMAC. So this will be our outline of this today's topic. So let us see the authentication requirement. So the first point of authentication requirement is disclosure. So disclosure is something that release of message content to any person or process not possessing the appropriate cryptographic key. So it is something that the message content to any person should not be possessing the appropriate cryptographic key. Okay, so next is your traffic analysis. So traffic analysis is something that discover of a pattern of traffic between the parties, that is from the sender to the receiver. So here in connection oriented application, the frequency and the duration of the connection could be determined. So in either a connection oriented or connectionless environment, the number and the length of the message between the two parties, that is from senders to receiver, could be determined. Next one is your masquerade. Masquerade is something that insertion of message into the network from a fault-tolerant source. This include creation of messages by an opponent that are supposed to come from an authorized entity, and also it included a fault-tolerant acknowledgement of message receipts or non-receipt by someone other than the message recipient. Next is content modification. So let us see if any changes to the content of the message, that may be insertion or deletion or transposition, and modification. Next is your sequence modification. Sequence modification is something that the sequence of messages between the parties. It also included something that insertion, deletion, and reordering. And next thing is that time modification. So time modification is something that delay or replay of messages. So here in connection oriented application, an entire session or a sequence of messages can be replayed of some previous valid sessions. So in a connectionless application, an individual message could be delayed or replayed. So in continuation with this connection oriented application, let us see about source repudiation. So denial of transmission of message by source, and destination repudiation is something that denial of receipt of message by destination. So let us see about the message authentication function. So message authentication is something that protecting the integrity of message and also validating it, that is its identity to the originator and non-repetition of the origin. Next is three alternative function which is used in this. One is your message encryption, and then next thing is your message authentication code, and last one is your hash function. So you all clearly know about what is message encryption. So message encryption is by itself, which provides a measure of authentication. If symmetric authentication is used, then the receiver knows the sender must have created it, and also only sender and receiver has key, which they have a symmetric key, same key, and the content cannot be altered. So provides both sender authentication and message authenticity. So next is your message encryption. So message encryption is if a public key encryption is used, that is encryption provides no confidence of the sender, since any one of the potentially knows the public key. However, if the sender signs a message using this private key, then the encrypted with recipient with public key have both security and authentication, but at cost of two public keys users on this message, similar to your bank. So this is an example how the message is delivered between source and destination. So how the message is delivered with the help of symmetric encryption and also public key encryption, and parallelly public key encryption with authentication and signature. Next is message authentication. So message authentication is a small fixed size of block of data. It depends upon both message and secret key. Like encryption throughout, it need not be reversible, and it also has a private signature, and receiver performs the same computation on messages and also check it that it is matches with the MAC. and it provides assurance that a message is unaltered and come from a sender. So this is an example how message authentication code done. So here you have two communicating parties, one it represented by A and B, which has a common secret key that is named here as K. So when A has a message to send a B, it calculates MAC as a function of the message and the key. So here MAC is equal to C, that is K comma M, where K represents the shard of secret key and C represents MAC's function and M is an input message. So next, in continuation with this, let us see about MAC authentication codes. So MAC provides authentication. So messages can be encrypted for secrecy. Generally, it uses separate key for each and can compute MAC either before or after encryption and is generally regarded as better than before. Why use of MAC? So why go for MAC? It's something that sometimes only authentication is needed and also sometimes need authentication to persist longer than an encryption. So let us see about MAC encryption. So here the receiver is assured that the message is from the sender, that is authorized sender, because no one can else know the secret key and no one could not prepare a message with proper MAC. Next, let us see about the MAC properties. So these are the properties of cryptographic checksum, where MAC equal to CK. So C is a function which has a variable length of M and secret key of K to a fixed size authenticator, and many to one is function. So potentially many messages have same MAC, but finding these needs to be very difficult. So these are the requirement of MAC. So MAC is need to satisfy the following requirements, that is knowing a message and MAC, and it's infeasible to find another message with same MAC, and MAC should be uniformly distributed and should not depend equally on all bits of messages. So if you have any clarification related to this topic, please feel free to approach me. Thank you.